Hello, hi. Welcome to the new video. Here in this particular video, I came up with a new job description for kind of preparation interview question and answers. So it is a company, 3i Technologies, sorry, 3i Infotech, and here the role was cloud as well as DevOps engineer. Here they are looking for 4+ years, around close to 4 years of experience in the engineers who have experience in designing automation and managing the scalable cloud infrastructure and CI/CD pipelines by using the GitHub. And these are the some skill sets they are expecting. So here the key responsibilities include CI/CD and automation. They need to design, implement, and maintain the end-to-end CI/CD pipelines by using the Jenkins, GitLab CI/CD, and Azure, GitHub Actions. And they need to be responsible for automate the builds, test, and deploy the workflow and the container the application. And but they need to maintain the workflow for both the containerized as well as non-containerized applications. And also, they are responsible for integrating the security scanning tools into the pipelines that includes SonarQube, Fortify, Trivy within the pipelines, and implement the blueprint and Canary deployment strategies within the Kubernetes environment. And they are expecting a cloud infrastructure knowledge on AWS and as well as GCP. These are the some popular or widely used services they are mentioned, and also a expectation with respect to containerization and orchestration and monitoring and observability, security and compliance, and some scripting as well as system administration skills. And these are the some required skills and qualifications which already covered above. And they are also expecting knowledge on security, which is DevSecOps practices, and knowledge on security tools. So now I have prepared the questions per the requirement. So I will be going through uh, the category of questions first. Later, we'll start with the discussion. So in the first category, we'll be discussing questions with respect to the CI/CD and automation. Later, the questions with respect to the cloud infrastructure, AWS and GCP. Later, containerization and orchestration, which is Kubernetes, Helm, Docker, and then monitoring and observability, which is Prometheus and Grafana related questions. Later, we will be discussing on security and DevSecOps. So that includes the tools as well as DevSecOps practices, everything. And then we will be seeing the final category of questions, which is some system administration and automation by using shell script, Linux, Bash scripting, Python scripting. Okay. So without further ado, let's enter into the discussion. So coming to the first question, where the question was, what is the key architectural difference between the Jenkins, GitLab CI, and GitHub Actions? So here, firstly, the Jenkins. It is a primarily self-hosted server that you manage yourself, and it runs as a Java application, and it relies heavily on plugins for functionality purpose. So it uses a Groovy for the pipeline logic flow, which is powerful, but it has a steeper learning curve, and it has around 1800 plus plugins, and it supports both the scripted as well as declarative syntax pipelines. And coming to the GitLab CI/CD, where it is integrated directly into the GitLab platform. So it uses YAML, which is this is the file name which mandatorily we need to do like this and dot GitLab-ci.yml. So which is stored in your repository wherever you are running the pipeline. And it runs on the shared runner, which is provided by the GitLab or as self-hosted runners also we can configure. And here, the configuration is tightly coupled with the Git repository interface. And the entire configuration we need to do within that only. And we need to configure the runners. There will be Windows runners, there will be a Docker runners. There are different runners. We need to configure that if we want self-hosted runners. And coming to the GitHub Actions, which is it is also a SaaS integrated service within the GitHub. How the GitLab within GitLab, GitLab CI/CD within GitHub. Likewise, this is the GitHub Actions. So within GitHub, so it also uses a YAML workflow, which was a file stored in the .github/workflows directory. So it is event driven, meaning it triggers specifically on the GitHub events. There will be a push based events, there will be pull request events, forks, and it relies heavily on the GitHub workspace for pre-built actions. So this is exactly the key difference between the Jenkins, GitLab CI/CD, and GitHub Actions. And coming to the second question, which is how are the security and quality scanning tools, especially like SonarQube, Fortify, and Trivy, which was integrated into the CI/CD pipeline. So here, basically, it is a question with respect to how these can be integrated into the CI/CD pipeline. So these tools can be integrated into the specific stages or the steps within the pipeline. So typically, after the build stage, but before the deployment stage, obviously. So coming to the first tool, which is SonarQube, so which is used for static application security testing. So it is basically helps to detect the code smells as well as bugs within the source code. So we add a step in the pipeline that runs a scanner, which is agent like the Sonar scanner like that. So it analyzes the source code and it sends the reports to the SonarQube server. And also it we can set it as we can display the results within the Jenkins UI also. So the developer can do that also. And they have the SonarQube access also. And coming to this Fortify, it is also a solution for SASH as well as a dash static and dynamic application security testing. So it scans the compiled binaries and the pipeline triggers a Fortify scan. And if the, I mean, we can set up, let's say, we found a high seniority issue, we can fail the pipeline. That means that particular build. So the pipeline will fail and it will send a feedback to the respective team or developer. Then they will work on the fix. And coming to the Trivy, which is a Docker image scanning tool. So it is used for scanning the container images for vulnerabilities. So in a Docker build pipeline, after the image was created, that means image was built, we need to run three image and then image name to scan. So if critical OS level vulnerabilities are found, the pipeline will prevent the image from being pushed into the registry. So this is how the scanning tools can be integrated into the pipeline. And coming to the third question, which is what is the difference between blue, green, and canary deployment strategies, particularly within the Kubernetes environment? So first one, blue-green deployment strategy. So this particular strategy maintains a two identical production environments. That means the two same production environments. One was blue that indicates the current version, and another was green that indicates the new version which we are going to deploy the application. So especially in the Kubernetes, we deploy the new version to a new deployment or a service. So once the green deployment passes the health checks, so then only we switch the service traffic from blue to the green instantly. So this creates a zero downtime, but it requires double the resources capacity. And coming to the another deployment, which is canary deployment. So this particular strategy updates a small subset of the instances, like 5% of the traffic, to the new version, while keeping everything, which is 95% of the traffic, to the old version itself. Especially in the Kubernetes, we might use two deployments with a different replica sets, and we adjust the traffic split slowly. So this allows us to monitor our errors in a live production environment with minimal blast radius before it was rolling out to all 100% traffic. Coming to the another question, which is how does the pipeline workflow differ for deployment containerized applications versus non-containerized applications? So it is basically with deploying the containerized application and deploying the non-containerized applications. So here for containerized application, so the workflow involves building a Docker image first with the help of a Docker file, and then we are pushing that particular image into a container registry like ECR or Docker Hub or GCR, like whatever we are using, and then we are updating a Kubernetes manifest file or is Helm-based deployment if you are using to a point to the new image tag. I mean, by pointing to the new image tag. So then the deployment applies the manifest to the cluster. And coming to the non-containerized workflow, so here the workflow involves compiling the code into a binary, which is a jar or var or some executable format, and then creating a archive that is zipping that or is tar if it is Linux, and then pushing this artifact to a repository like the artifact repository like Nexus or as some JFrog artifact repository. So here the deployment stage when connects to a virtual machine via the SSH or some Ansible configuration. So it stops running the service and it uploads the new binary and it restarts the service. So this is how exactly the workflow differs between the deploying the application for containerized as well as non-containerized applications. And moving further, the fifth question. So, what is the concept of pipeline as a code and how it is implemented by using the AML files? So, here, yes, we can say pipeline as a code means defining the stages like build, test, deploy logics in a text file which was stored within the source code repository, rather than configuring it manually by using the graphical user interface, that means any application interface. And coming to the implementation part, so here, especially with respect to the YAML, we create a YAML file, especially if it is a GitLab, then it will be .gitlab -ci dot YAML file, or else main.yaml file. Uh, and if it is Jenkins, then it will be Jenkins file. If it is GitHub Actions, main.yaml file. So it will be created, it is created in the root of that particular project directly. Sorry, project directory. And this particular file contains the definition of the stages along with the jobs and what exactly the steps we need to perform by using the specific syntax. If it is Jenkins, it is Trivy. If it is GitLab, then it will be YAML syntax. So when the code is committed to that particular repository, then the particular CI/CD pipeline system will detect the file automatically, and it creates the particular pipeline structure which was defined within it. So this allows the pipeline to be version controlled managed, and we can be reviewed and rolled back just like a application code. So this is exactly the concept of pipeline as a code and how it was implemented by using the YAML files. And coming to the sixth question, how are the rollout strategies automated within the CI/CD pipelines to recover from failed deployments? Here, the automated rollouts are usually handled by the deployment tool or the deployment platform. Within, especially with respect to the Kubernetes, if your deployment is fail, let's say example, pod is crashing repeatedly, so the replica set controller automatically rolls back to the previous stable replica set in a pipeline. So in a pipeline, we can configure a rollback job that triggers manually or else automatically also if the health check fails. That means by running a health rollback or else kubectl rollout undo command. So that is how it works in the Kubernetes rollback strategies. And coming to the in automation, with respect to the cloud formation and Terraform. So uh, if the infrastructure update fails, the tool automatically triggers a stack rollback to the previous known good state. So in the virtual machine deployment case, we can use the artifact version. So if the new binary, which is version 2.0 failing, so the rollback job simply deploys the previous binary, which is version 1.0. So that was stored within the artifact repository. So this is how exactly the rollback strategies automated within the pipeline workflows. And moving to the seventh question, that is what mechanisms are used to protect the pipelines. There might be multiple mechanisms like webhooks, pollings, as well as schedules within the GitOps workflows. So coming to the first figure, which is webhooks. So this is one of the standard for the GitOps workflow. When the code is pushed, or else when the code is pulled, when we receive a pull request from the Git repository, or else whatever the source code repository, then it sends a HTTP post, which is a webhook based ticket to the CI/CD server, and then it instantly triggers the particular pipeline, and then that particular pipeline will be good. And coming to the second model, which is the rolling mechanism. So here, sorry, the polling mechanism. That means that particular CI server will periodically checks whether that particular source code repository, that might be Git or every week. So it will check each and every minute or whatever the frequency we set up. Let's say if there is a new commit in that particular time frame, then it will pulls that particular newly committed code, and it will trigger the pipeline. And coming to the third trigger, which is schedules, that means basically the cron syntax. So we can trigger that particular pipeline in a specific time frame. So let's say if that need to be run every morning at 7 a.m., we can build that particular pipeline within the particular time frame. So these are the three triggers, which was webhooks, polling, and schedules within the pipeline, how it works. And coming to like how exactly the build artifacts stored and versioned to ensure consistency across the environments. There might be multiple environments. There might be staging, dev, or production environments. So here, the build artifacts basically that might be the binaries or that might be the Docker images or some packages, whatever you are storing in the artifact repository tools like Nexus or JFrog artifact. It is basically, let's say, if we are using some registries, especially if we are building the images out of the artifacts, then we might be using some artifact sorry, container registry tools, which is Docker Hub, or some, if we are using AWS, which is Elastic Container Registry, or if it is GCP, it is Kubernetes registry. And then we are going to version that. I mean, this is the process. First, the artifact will be stored in the artifact repository manager, and then the image will be published into the registries. If you are building the image, then it will be versioned. That means instead of overwhelming that particular file, we tag that with a unique version number. So especially for the containers, we uh, include the semantic tags that will be in this particular format. So there will be a like what exactly the main version, and then if there is any subversion it is there, then that will be indicated with this. And if there is any bug fix or like whatever recent changes with respect to the security bug fixes, that will be indicated with this format. So uh, when coming to the promotion part to a different environment, especially the dev production, we reference that particular specific immutable version tag. So that will ensure that the exact same binaries which is running in the test environment later to the UAV and later to the production environment. So this is how exactly the build artifacts are stored and maintained a consistency among the environments. And moving to the cloud infrastructure, basically like what exactly the key differences between managing the compute resources with respect to the EC2, GCP, or compute engine like that. So here, both the providers are IaaS, which is infrastructure as a service. So here, these are the virtual machines, but those are, I mean, who were managing those are different. That's it. And coming to the EC2, which is the AWS EC2, it uses the concepts like AMS, which is the Amazon Mission Image, to launch that particular instance. And there will be a security groups concept via the virtual firewalls, which was attached to that particular instance. So it offers a wide variety of instance, which was familiar optimizer for compute memory as well as the storage optimizer. So these are the instance types basically. And coming to the GCP compute engine, so it uses the images on the instance templates. Uh, Here, the security is managed by using the VPC firewalls, which is up, applied at the network or else instance levels. So here, the GCP often emphasizes the custom mission types, uh, where you can fine tune where exactly the uh, virtual CPUs as well as the memory ratios you need, whereas AWS has a fixed instance sizes. So this is exactly the different, I mean, it differentiates managing the compute resources between the AWS as well as the GCP. And moving further, like how exactly the Terraform state is managed within the team environment, and how exactly the state logging mechanism, or how important that here whenever you are working with the team environment. First of all, the state management. So here the Terraform stores the state in your infrastructure. So it is the mapping between your code and the real cloud resources. Basically, the Terraform.tf state. This is exactly the file. So let's say in a team, how this particular file is stored remotely in the backend, like AWS S3, or else if it is Google Cloud Storage. So everyone can access it. And coming to the locking mechanism, state locking mechanism. Let's say when the engineer runs this particular Terraform apply command, uh, the Terraform places a lock on the state file. This prevents another engineer from running that particular same command on the same instance at the same time. So let's say if without logging, the concurrent uh, applies will happen, and it will corrupt the state file also. And then it causes a mismatch between the actual infrastructure in the cloud and it leading to failed deployments. So this is how exactly the state management, whenever the environment and the state logging mechanism works within the data. And here, like what exactly differs between the Terraform declarative as well as Ansible, like procedural or imperative syntax or the model. So the Terraform, which is a declarative, it works in a declarative manner. So what exactly that means was where you are going to define like what exactly the infrastructure you need to provision. It looks like I want three web servers. So Terraform calculates the steps required to achieve that particular thing, and that state and it executes them. So it manages the life cycle of the cloud resources. That means it creates, it updates, and it deletes also. And coming to the Ansible, it is procedural as well as we can also say imperative. So that what exactly that means was you are going to define how to achieve the state by using a sequence of flags. That means we need to install a package A, then we need to start the service B. So it runs the scripts or its modules on the target servers to configure the OS or else some software. So it primarily focusing on the configuration management part rather than infrastructure person. So this is exactly what makes the difference between the Terraform and Ansible. And how is the secure VPC, which is virtual private cloud architecture, which was designed by using the subnets, private security groups, and NGCS as well as VPC pairing. So here, a secure design uses a layered security. So let's discuss what exactly the layered security was. Here, first of all, subnets. So here we created public subnets. So that means within the internet gateway router. So for the resources, you need the internet access, especially the load balancer, some bastion host, and we are using the private subnets. So there is no direct route to the internet. So especially for the databases and application servers to prevent a direct external access. And we are going to another layer of security was security group, which is network access control lists, NACLs we can say. So we use network access control lists, which is basically NACLs, at the subnet level to basically whether that will allow or deny the traffic ranges uh, from layer 3 or layer 4. So we can use here the security groups at the instance level. It basically allows a specific port traffic. Let's say, for example, port 80 from the load balancer only. That means it allows only port 80 to travel from load balancer and that looks only one way traffic based upon our configuration, I mean security groups and coming to the another layered security was VPC peering. That means this connects two VPCs privately by using a private IP addresses. So we enforce there will be a strict routing tables as well as security group rules to ensure that only specific subnets within one VPC can be communicated with a specific subnet in the peered VPC only. So this is how to secure the VPC architecture by designing a subnets, security groups, NACLs, and VPC peering. And moving further, where we will be discussing what is the role of cloud formation alongside the Terraform in a hybrid cloud infrastructure strategy. So here, while the Terraform is a multi-cloud and it is popular, and coming to the cloud formation, it is AWS native solution. It is often support for new AWS futures faster. So in a hybrid strategy, cloud formation might be used for AWS specific stacks or else AWS specific tasks that requires deep integration with the AWS services, especially like nesting stacks or by using the AWS macros like that. So coming to the Terraform, where it is used for core cross-platform, uh, it is I mean, especially for the cross-platform infrastructure, or else if you are using multi-cloud setups, in that case we can use. So sometimes use it the Terraform for to orchestrate the cloud formation stack, or else vice versa. It primarily depends on their existing automation tasks and their team expertise also. And coming to the another question, like how are the cost optimization strategies? There will be some strategies will be implemented for cloud resources, especially the reverted instances, sorry, reserved instances, lifecycle policies. Like how exactly the cost optimization is done. So, with respect to the cost optimization, there is a reserved instances, which we can say RI instances. So, it is basically a saving plans. So, we analyze the uses basically the metrics for long running workloads. Let's say if the servers run 24 by 7 for entire year, we purchase basically a reserved instances. That means we are committing to 1 or 3 years from significantly, I mean, that significantly reduces the hourly cost compared to the on-demand pricing. And there will be a license policies also, sorry, life cycle policies also, especially for storage. There will be a S3 or else a cloud storage. So we define the rules to move the data to a cheaper storage classes over the time. Let's say, for example, the data moves from standard to some infrequent access. Let's say for after 30 days we need to access it. And let's say if it is not even accessible after 30 days also, then it will be moved to the glacier, that means archive storage, which is called after 90 days. So we can also automate the deletion of old logs or snapshots to basically prevent the storage costs. And uh, it is basically, these are the some strategies with respect to the optimizing cost of the cloud resources. And moving further, where we will be discussing on how exactly the serverless functions, basically the AWS Lambda function, or if it is GCP, if that will be uh, Google Cloud function, GCP function, which was integrated into the CI/CD pipeline. So here, coming to the workflow, here the integration involves deploying the function code that will be in zip file, or else that might be in container image format to the cloud provider. So coming to the AWS Lambda, so here the pipeline builds as a code. Basically, that might be a Node.js or Python, and it zips it, and then it uses the AWS CLI, which is serverless framework, or else the Terraform to basically update the Lambda function. Uh, Lambda function code, and it updates the alias function also. And coming to the GCP functions, so the pipelines will deploy the source code by using the G Cloud functions deploy. So this is the command, or else we can use Terraform also. So here the pipeline also configures the trigger, let's say example, an HTTP URL, or else an S3 event, or else a pub sub topic, and it updates the environment variables required by that particular function. And moving to the another question, like what exactly the network differences between the AWS VPC and GCP VPC regarding regional subnets. So here, with respect to the AWS VPC, obviously, a VPC is a regional in AWS, and the subnets are tied to availability zones. So we can say AWS, AZs. So you must explicitly create a subnets in specific availability zones to ensure high availability. And coming to the GCP VPC, so here the VPC is a global service in GCP. That means it spans for all the regions in the world. So, however, these particular subnets are regional. So, within that particular region, you can create a subnet and you can span all and to entire zones, which was comes under that particular regions. That is basically we can say regional subnets, or else we can say specific zones. That means zonal subnets also will be available. And coming to the implication, how it will be implicated, especially in the AWS, you must automatically manage that particular networking across the availability zones. And in GCP, as I said, it is a regional subnets, so it will automatically inherit and it will cover the resources to all the zones which was comes under that particular region. And here, specifying the network topology slightly, and then through the replacement, it still repeats it still respects the specific zones. So these are the questions with respect to cloud, GCP, and AWS. Moving to the other category of questions, which is containerization and orchestration, which is the questions with respect to Docker, as well as Kubernetes and Helm. So here, how do multi-stage builds optimize the size of your Docker image? So here, a multi-stage build, it basically allows you to use the multiple from statements, basically from commands, we can say, in a single Docker file. So in the particular first stage, we use heavy image like Golang or else a Maven package. And then that contains the compilers to build that particular application source code into the executable binary format. So in the second stage, we use the lightweight minimal packages like Alpine or else distroless. So we use the copy only command, copy only argument from zero. That means from the earlier stage one. So it basically copies only the compiled binaries from the first stage into the second stage. So as a final result, the file a Docker image that contains the only application and its associated binaries as well as associated runtime dependencies will be there. And it won't include all the compiler as well as the build tools, and it will obviously reduces the image size and attack surface also. So this is how exactly the multi-stage build, uh, especially with respect to optimizing the Docker image works. And moving to the further, like what are the core concepts of Kubernetes control plane? So here there will be some concepts, primarily five we can say, uh, for API server, PTCB, scheduler, controller, manager. So here the control plane, it manages the state of that particular cluster. And coming to the components, first of all, API server. It is the important one, and it is a central management point. So it validates and also it configures the data for API objects, for the pods, services like that, and it acts as a front door for all the particular commands. That means whatever the commands we are going to interact, that will contact and talk with the API server only. And coming to the ETCD, which is a database, we can say. So it is a consistent and high available key value stored. So it is a database for the cluster, and it stores all the cluster data. Basically, that includes the configuration and state data. And coming to the other component, which is a scheduler. So what exactly scheduler does was it watches for the newly created pods that has no nodes assigned to that particular pods. So it selects a node for them to run on based upon the resource as well as requirements and associated hardware software policy constraints, and there will be a concept of affinity and anti-affinity specifications also. So this is what exactly the scheduler is. We come into the controller manager. So basically it runs a controller process. So that includes the node controller, replication controller. So it loops constantly to watch the current state of the cluster, and it makes the changes to move the actual state toward the desired state. So these are the like components within the Kubernetes workflow. And moving further, where the question was with respect to how to manage your Kubernetes services like AWS EKS, Google GKE, specifically the cluster management. Here, the managed services offloads the responsibility of managing the control plane. Basically, the master nodes, we can say, to the cloud provider. That means it will be managed by the cloud provider, whatever AWS or GCP or Azure, whatever it is. So here, the high availability will be maintained. Uh, let's say if it is AWS or GCP, it will ensure the master nodes are highly available, and it applies the patches automatically. And coming to the upgrades, that means they handle the upgrades of the Kubernetes API server and underlying control plane components also. And coming to the scalability also. So they manage the etcd storage and scaling of the control plane. So the user is still responsible for nodes. The user need to manage them where the containers exactly running. So unless they use a serverless or as Fargate or autopilot mode, then they no need to manage. Otherwise, they need to manage it. So coming to the another question, what are the roles of Helm in Kubernetes deployments, and how are the Helm charts structured? So here, first of all, Helm is a package manager for Kubernetes. It is similar to apt or M within the Linux. So it helps you to define, to install, to upgrade the complex Kubernetes applications. So here, the Helm chart is a collection of files that describe a related set of Kubernetes resources. So that basically contains the chart.yaml file. So that is the metadata about the chart, Helm chart. And there will be values.yaml file. So it defines the configuration values, and there will be templates folder. So it is a directory of your template files that generate a Kubernetes manifest files with respect to the deployment, services, config maps, everything. When you run Helm install, so Helm combines the templates with the values to create the fine Kubernetes objects. So this is how exactly, or like what exactly the role of Helm within the Kubernetes deployment. And coming to the another question, where how do Kubernetes services like cluster IP, node pool, load balancer manage the work exposure? Sorry, manage the network exposure. So here the services abstract the physical IPs of pods and that will provide a stable network endpoint. First of all, the cluster IP. So what exactly the functionality of the cluster IP was? It exposes the service on an internal cluster IP. So it is only reachable from within the cluster. So this is the default type service we can say. And coming to the node port, so it exposes the service on each node's IP at a static port. So you can access the service from outside the world of the cluster by requesting whatever the node IP and node port is there like this. And coming to the load balancer, so it basically provisions an external load balancer from AWS or GCP, etc., that routes the traffic to the service. So it assigns a fixed external IP to the service that making it accessible from the outside internet. And this is how exactly the Kubernetes services manage the network exposure. And coming to the another question, like what is an ingress controller and how does it differ from the load balancer? So here, the ingress controller is acts as an intelligent entry point for HTTP as well as HTTPS traffic, while the load balancer typically works on layer 4, which is the TCP and UDP. Here, the load balancer, as I said, the layer 4, it routes the traffic based upon the IP and based upon the port. One IP is equal to one service. It acts like that. And coming to the ingress, it typically works on the layer 7. So it routes the traffic based upon the HTTP attribute like host name uh, or else api.example.com or else path-based routing. So a single ingress controller like Nginx can route the traffic to a dozens of different internal services based upon the URLs, and it saves the cost and simplifying the management also. So this is how exactly the like ingress controller as well as load balancer differs each other. And moving to the another question, like how are persistent storage requirements handles the Kubernetes by using the persistent volumes and persistent volume claims, PVCs we can say. So here, Kubernetes decouples the storage from the pod lifecycle by using these two objects. One was persistent volume and persistent volume claim. So here, a persistent volume, it is a piece of storage within the cluster that which was provisioned manually or else dynamically. So that has a life cycle independent of any individual pod. So it represents the actual physical storage resource. Example, AWS EBS disk. So this is the persistent volume. And coming to the persistent volume claim, so it is a request for storage by user or the pod. So it specifies what exactly the size and the access mode. That means read, write once, or read-only access. So the Kubernetes system, it binds the PVCs to a compatible PV. So the pod then it mounts the PVC, which is a persistent volume client, as a volume. If the pod dies and is recreated, recreated, the uh, here the PVC data will remain the same. So that is the use case of persistent volume as well as persistent volume claim. So here, like what exactly makes the difference between the config maps as well as secrets within the Kubernetes. So here, obviously, both are injected while configuring with both are used while injecting the data in the configuration. First of all, the config maps. So it is used to store the basically the free data, which is confidential data. So it is basically a key value file which was consumed as an environment variable or else even a simple command line argument also. And it can be stored within a plain text format also. And coming to the secret, so it is storing a sensitive data, especially like API tokens or some authentication tokens or passwords or SSH keys. So this particular data is encoded in the base 64 format, and we also enable the auto encryption also. And then we mounted that files as environment variables within the Kubernetes, and that particular Kubernetes also supports the integration of those secrets as an external vault also, like AWS Secret Manager or Azure Key Vault or HashiCorp or like any of the third-party vaults also. So this is how exactly the config maps as well as secrets differ within the Kubernetes. And coming to the monitoring as well as observability, primarily the Prometheus and Grafana. So here, how does the Grafana, basically the Prometheus, first the data, and how exactly the push-based mechanism differs from the pull-based mechanism. Here, the Prometheus, which works on the pull-based mechanism. So here, the Prometheus server effectively scraps, that means it pulls the targets by sending a HTTP request to the metrics endpoint. Example, let's say metrics, this particular folder, and it exposed by that particular application or else the node exported. And then it discovers the target via the service discovery. And then if, let's say, the target is shuts down, then it scraps the fail and the Prometheus will detect the outage immediately. And coming to the push-based model, it is a traditional where agents which was running on the target servers, it collects the data and then it pushes it to the actual central monitoring server. So this can be overwhelmed and the central server, if the thousands of agents push the data simultaneously, and it requires the central server to be reachable from the targets also. So this is how the Prometheus full model differs from the traditional push-based monitoring agents. And coming to the another question, like, what is the function of Grafana in monitoring stack and how does it query Prometheus? So here, Grafana is an open source analytics and visualization platform. It does not store the metrics itself, so it requires the data resource of the Prometheus. Here, coming to the function, so how exactly it function? We build the dashboards within the Grafana containing the panels that basically having the graphs, gauges, tables. And coming to the querying part, so here Grafana uses a prompt QL, which is a Prometheus query language, native language, to send the queries to the Prometheus API. For example, this was the one query. So here the Prometheus returns the time series data, and Grafana will renders it visually on the dashboard for the users. So moving to the further question, where the question with respect to how are alerts configured and managed in Prometheus by using a or alert manager. So here, alerting is a two-step process. One was Prometheus and basically evaluation and then routing alert manager. First, Prometheus, which is a evaluation we can say. So we are going to define the alert roles in Prometheus by using a configuration files. Here, Prometheus periodically evaluates those rules against the scrapped metrics. Let's say if the condition met, let's say example, we set the condition as if the CPU usage uh, is greater than 90% for continuous 5 minutes. So it finds the alerts and it sends the uh, alert to the alert manager. And coming to the alert manager, which is a routing where the alert manager receives the alerts and groups a similar alerts together. That means a duplication, if it is there, that will groups together, and it routes them to the correct receivers. That might be emails or some Slack groups or PagerDuty. So it based upon the routing labels. So it also handles the silencing and in addition of alerts. So we can set up those alerting roles and configuration. And coming to the another question, like what exactly the difference between the metrics and the logs and why are both are needed? Prometheus for metrics and logs for the PLK stack or some stack driver. So here metrics, which is the numerical data which points a measured over the time. Example CPU usage, request latency. So they're pre-aggregated and which was stored in the time series database. So they are excellent for spotting the trends, spotting the generating the alerts also, and understanding like what is happening. So that is the use case of metrics. And coming to the logs. So these are the text records of discrete events. Example was error connecting to DB. So they provide a granular detail. So they are essential for debugging why exactly it is happened. So coming to why both is required. So here the metrics tells you like when a problem occurs via the alerting mechanism. And coming to the logs, it allows you to investigate the root causes by reading the specific error message which was generated during this particular time frame. So this is why exactly both logs and metrics are required. And coming to the another question where how is high availability, which is 99.9% uptime, ensured through the proactive monitoring and alerting? So here we ensure a horizontal pod autoscaler, sorry, horizontal autoscaler by monitoring three layers. So sorry, it is not horizontal autoscaling or something. It is high availability. Sorry. So by ensuring, by monitoring these three layers, we ensure high availability is achievable. First one was infrastructure, later application, and business logic. So in the infrastructure layer, so we monitor basically what is the metrics, like basically the CPU, memory, and this, uh, and the, like on the underlying nodes, how exactly this infrastructure metrics are. And the application where we monitor the health endpoints. Uh, that means it basically this like what exactly the response time, what is the latency of that will be known with that application layer. And then in the another layer, which is business logic layer, where we monitor the transaction success rates. So we configure the alert thresholds where well before the point of failure. Let's say example alert at 80% of CPU, not at 99.9% or something like that. So we also set up a synthetic monitoring where it simulated user requests. So to detect the issues before the real users do. So by receiving early alerts, we can auto scale or else we can also remediate the issue before the actual cause of the downtime. And coming to the another question, like what is the purpose of a push gateway in Prometheus for short-lived jobs? So here the push gateway acts as an intermediary for short-lived jobs, basically cron jobs or batch scripts. So these jobs exist only for a few seconds. It is too short for Prometheus to discover as well as to scrape them reliably. So instead, that particular job pushes its metrics to the push gateway before it exciting. Sorry, before it exiting. So the Prometheus then it scraps the push gateway to retrieve those particular metrics. So it is essentially catches the metrics for the short-lived job and then the Prometheus picks them up. So this is like what exactly the purpose of a push gateway within the Prometheus for short-lived jobs. And come to the another category of questions, which is security and DevSecOps. So here, how are the IAM roles and policies designed to enforce the principle of least privileges? So here, the least privilege means granting the users or else the service only the specific permissions which was required to perform the actual task and nothing more than that. That is the like concept of least privileges. Coming to the design part, where we create a IAM policies which are adjacent documents that defines the permissions. That means what to allow, what to deny actions for specific resources. So we attach those policies to the roles for services or users also. And coming to the implementation part, so instead of assigning a generic administrator policy, we write a specific policy that includes, let's say example, allow S3 bucket get object only on this particular like path. And also one more implementation was good practice was we regularly audit these particular policies to remove the unused permissions. And also there will be one more good practice for implementation. So this limits the blast radius of the compromise If a specific service account is hacked, the attacker can only access the resources which was tied to that particular specific role. So this is how exactly the IAM roles and policies defined to ensure a principle of least privileges. And coming to the another question, which is the respect to what are the differences between the AWS Secret Manager and GCP Secret Manager and HashiCorp Vault, which is a third-party secret manager? So here, these three tools securely, in use case, was securely store the sensitive data, but the scope and features are different. Coming to the AWS Secret Manager and GCP Secret Manager, um, these are the cloud native services which was offered by the cloud public cloud service providers. So they integrate deeply within the clouds IAM, which is the identity and access management level. So they offer automatic rotation of the secrets, like the database passwords or some API keys or some passwords. So especially for it is supported for RDS and the cloud SQL databases. So they are easiest to use if you use fully within the specific cloud ecosystem. And coming to the third-party service provider, which is HashiCorp Vault, it is an open source vendor agnostic tool. So it can run and it can run on any cloud or in on-prem also. So it offers a advanced features like dynamic secrets. That means generating a new database credentials on the fly that expires after the short time and encryption of the service. So it is preferred for complex as well as a multi-cloud and hybrid environments. This basically HashiCorp Vault. And coming to the another question, like where is SSL and TLS termination best handled at the load balancer, the ingress controller, or the application layer. So here, the termination is the process of decrypting the encrypted HTTP traffic. So let's talk in all the layers. Coming to the load balancer, which is the most common we can say. So here we terminate the SSL at the cloud load balancers. That might be AWS load balancer, Google load balancer. So here the that particular cloud service load balancer handles the heavy computational loads of encryption as well as decryption also. Here, the traffic between the load balancer and the backend pods or instances is usually unencrypted or else re-encrypted. So this simplifies the certificate management also. And coming to the ingress controller, so we terminate the SSL at the Kubernetes ingress, example by using the engines. So this is useful for granular routing rules based on TLS or SNI or when using the mutual TLS, that means MTLS, mutual TLS between the services. And coming to the application, where rarely used for termination because it consumes the application CPU resources. It typically only used for end-to-end encryption, where the data must remain encrypted well, the data remain encrypted until it reaches to the application logic. So this is where the TLS and the SSL termination best handled at the load balancer and the ingress controller or application level. And coming to the other question, where the question with respect to what is shift left? So in the context of DevSecOps and also how it impacts the SDLC. So here the shift left security means moving the security testing and security checks at the earlier stages of the software development lifecycle, SDLC. That means the left side of the timeline or pipeline workflow. So here, the impact it shows on the SDLC was it in the design phase, we perform the threat modeling as a shift left security approach that will basically find the flaws before the code is written in the design level itself. And in the coding phase, where the developers runs a scan, static application security scan, the tools ideally works on the source code and it can be directly integrated into the IDE level also, integrated development environments, or for each and every code commit for that particular branch, we can integrate that. And coming to the build phase, where we integrate the SCA, software composition analysis, to check for vulnerable libraries, third-party components. So by finding and fixing the bugs in the like a design or coding phase, so the cost of the fix of finding and fixing those is significantly reduced um, rather than finding and like mitigating those bugs in the production. And coming to the another question, like how are the container image vulnerabilities scanned using a tools like a Trivy before deploying the application? So here, the Trivy is a comprehensive security scanner that looks for OS packages and the application dependencies, vulnerabilities, which is CVEs, which was associated with. And coming to the how exactly the workflow the scanner works. In the build stage, the Docker image is built within the CI/CD pipeline, and then we are going to perform the scan within the pipeline itself. So we run that particular command, Trivy image, and then whatever the image name was built. So here the Trivy downloads the vulnerability database, and then it compares the packages which was installed in the image against it. And then coming to the report and the fail criteria, Trivy outputs the report which was listing the vulnerabilities, and also we can set up a fail criteria if the vulnerability was critical or high or medium or low, and also the gate, the quality gate we can say. So the pipeline is configured to a fail or else stop the deployment if any critical or high severity vulnerabilities are detected. So this will obviously ensure there will be a compromise if there is a compromised images that will never reach till the production. So this is exactly how the container image vulnerability scanning tools like Trivy used before the deployments. And coming to the final category of questions, which is the questions with respect to system administration and some automation, basically scripting, Linux, Python, or Bash. Here, first question was, what are the essential Linux commands or the log files which was used for troubleshooting the system issues like Ubuntu, like that? So these are the some commands, and let's go one by one. First one was top and HTOP, where it uses to monitor the real-time CPU as well as memory usage, and DF5H, where it uses to check the disk space usage, which was mounted on the file system. And coming to the next tab or SS, basically it helps to check the open ports and active network connections also. And there will be a general CTL, where basically that helps to query the system in general. And coming to the log files and located at the var log, those are the, I mean, these are the some like commands for troubleshooting to check the logs, var log, syslog. So basically, general system messages or else var log messages it will know. And var log auth.log, where basically it includes the authentication logs, what else successful attempts or failed login attempts. Var log kernel.login, where basically kernel messages, and varlog nginx or varlog Apache. It basically the application specific web server logs will be included in this. So these are the some essential commands for troubleshooting for system issues, system related issues. And coming to the another question, where the question was, what are the primary use cases of a Boto3 library in the Python for AWS automation? So here, the Boto3 is a official AWS SDK for Python. So it allows Python scripts to interact with the AWS API programmatically. And so here, this is the primary use cases to provision the infrastructure automation, where it will help to create the HTML instances, launches the RDS databases, and creating the S3 buckets based upon the triggers. And there will be maintenance tasks also you can be performing this. So scripting the cleanup of old snapshot of or unattached EBS volumes to share the costs. And there will be a deployment task also. That means automating the upload of build artifacts to the S3 bucket and updating the Lambda functions code. And there will be used for data processing also. That means reading the data from DynamoDB or some SQS simple queuing service for processing the workflow. And coming to the another question, like what are the key constraints constructs, basically the variables, loops, conditions, which was used in Bash scripting for for task automations. So here, the Bash scripting is used to automate the Linux commands sequences. So in that, first constraint was labels. So here, it is for storing the data. So this is a use case of, this is a syntax use case for labels. Label name is equals to like whatever the value. So and there is no space in between the equals to. That means label name and label value. And coming to the loops, where it is used for iterating over the list of items. So this is the syntax where it is used to perform an action for multiple servers or multiple files. So if this particular for item is listed, we need to do this particular command. And then the conditions that includes the if else if else condition. So it is basically used for making the decisions based upon the exit codes or else the file systems, file existence or whatever the target existence. So this is the use case of this syntax. So it is basically used to check, let's say, if a service is running or else before restarting uh, that particular service. If exist and if it was running, then don't restart. Just print this message. If it's fixed and if it's not restart, if it is not running, then restart. In that case, we use this conditional statements. And coming to the functions constraints. So it is for grouping the reusable in the script. And like these are the some exactly the key constraints within the bash scripting for automation, which is used. And coming to the strategies, like what are the strategies for database backup and restoration? With let's say example RDS or Cloud SQL like that. Here there is a automated services which is automated backups, and there will be a process of manual snapshots also. Let's see like how the backups are taken and then restoration how it works. The automated backups, these services take the daily snapshots of the storage volumes and it will retain them for a configurable period. Let's say example before the support point in time recovery, that means PITR, to restore the databases to any specific second within a retention window. And coming to the manual snapshots, that means where we can initiate a manual snapshot that includes the DB snapshot, so which are retained until explicitly it was deleted. So these are useful for long-term archiving before a major changes are happened. And coming to the restoration process, so we can restore a snapshot to a new database instance to verify whether the data integrity within the or without overwriting the production database. And we can perform the point in time restoration also to basically helps to recover from human errors, especially like accidental deletion of the commands like that. And coming to the final question, like how the database queries optimized and monitored to improve the application performance. So here, coming to the optimization part, mm, I mean, we'll be discussing both the optimization and monitoring part also. And in the optimization, so there will be indexing and query referencing. In the indexing, where we will be creating indexes on the columns frequently by where I mean used in where join and order by classes. So this basically allows the databases to find the data repeatedly without scanning the entire table. That means a full table scan it won't perform. And coming to the query refactoring. That means rewriting the inefficient queries. That includes avoiding select star everything. That means and selecting only the needed columns only. And coming to the monitoring part, where there will be a slow query logs and performance insights. In the slow query logs, we will be enabling a logs that records the queries and taking a longer. I mean that are taking longer than the specific thresholds. And in the monitoring, there will be a performance insights also, which is using the tools like AWS RDS, performance insights, or Google Cloud SQL insights to basically visualize the data, load, and identify the top SQL statements consuming the CPU or input output resources. So yeah, these are the questions, and I wanted to be shared in this particular video, and I will be putting like all the resources whatever presented in this particular video in the description in the GitHub URL. So go through it and consider for your preparation too if you are preparing. And thank you so much for watching, and all the best for your preparation.